Hello, my name is Mike Friesenegger, and I am a solution architect working at SUSE, working with our IBM partnership. I'm also the co-chair for the Feilong project, which we'll be talking about today.
My name is Chen, and I work for IBM. Now I'm the Cloud Infrastructure Center Architect, which is an IBM Z and Linux One offering focused on the infrastructure as a service for IBM Z and Linux One platform. It's an honor for me to give this presentation to you guys. Thanks.
You might be asking yourself, what is a Feilong? In Mandarin, the word Feilong translates to flying dragon. Feilong is also in Chinese mythology, and it's a winged creature that flies among the clouds. I really like this definition of the winged creature flying among the clouds to represent what we do in the Feilong project. Yes, we don't fly around in the real clouds, but we are flying around or helping automate infrastructure as a service automation, or what many might think of as cloud-like services for the ZVM hypervisor. So let's take a moment to talk about the mission of the project, which is pretty simple. We want to allow anyone to contribute and further develop the RESTful API server that simplifies the interaction with the IBM ZVM hypervisor. You'll get to hear more about the technical aspects of the RESTful API server, but let me just take a moment to explain it at very simple terms. The ZVM hypervisor has no RESTful API server. If somebody wants to create a virtual machine or manage networking or manage storage, they have to do it via the command line that is provided by the ZVM hypervisor. With the RESTful API server, anybody that understands web-based programming can interact with this API server, which then drives the management of the virtual machines, the management of the networking and storage that would normally be done via the command line for the ZVM hypervisor. How does this benefit the community? Well, first of all, many thanks go to IBM for their contribution to the project, because from that contribution, we have a very strong code base that allows the community to use, contribute, and further develop the project. For developers that don't have a strong or deep knowledge of ZVM and how to interact with ZVM at the command line, now there's a RESTful API that's well-defined, that's published via the Feilong project, and the RESTful API server that makes it easier for those developers to interact with ZVM. And finally, the Feilong project allows individuals and organizations to develop their own self-service infrastructure as a service automation to manage the VMs, networking, and storage that are used by ZVM. Yes, you'll hear about OpenStack, and you'll hear about other tools that can interact with the Feilong codebase and the Feilong RESTful API server. But because it's a set of APIs, organizations can develop their own self-service automation if that's what they want to do. So what's next for the project? First of all, we needed to make sure that the CI/CD infrastructure that was developed and being done with an IBM before the code was contributed to the Open Mainframe Project. We needed to make sure that that CI/CD infrastructure is duplicated within the community. The CI/CD infrastructure that was used within IBM is Jenkins-based. We've chosen to use GitHub Actions. And so we're in the process of working to connect GitHub Actions to Z resources that are being provided by some of our Feilong partners. Secondly, we want to make sure that developers and anyone that wants to contribute to the Feilong can get access to ZVM resources so they can develop, test, and document features that they're working on. Again, these Z resources are being provided by our Feilong partners. The OMP has a great summer mentorship program, and this year marked the first mentorship project that focused on contributing to Feilong. Ansible automation for storage, actually SCSI-based LUN automation. And so we want to be able to support projects like this, not only this project for this year, but ongoing OMP summer mentorship programs. We want to be able to promote ideas on how students and mentors could contribute to the Feilong project. And lastly, this is near and dear to my heart as the co-chair of the Feilong project, but I'd like to see ways that we can increase the Feilong membership. Not only the membership that contributes and takes advantage of the Feilong codebase, but also the members that regularly attend our scheduled project meetings. I would love to see that to be able to grow. So if you're interested in hearing more about Feilong, I encourage you to check out our regularly scheduled project meetings that happen every other week. And with that, I'd like to turn it over to Jay Chen to go into more technical details about the Feilong project.
Thank you, Mike. So next, I'm going to give the technical introduction about the Feilong project. So here's the architecture about Feilong. As you can see here, actually I'm using an OpenStack offering as an example. The Feilong is we used to call it ZVM Cloud Connector, which is something that sits between some offering like OpenStack and the ZVM platform. There is no existing REST API layer on top of ZVM. It only has a socket connection, which is called SM API, System Management API. Right? So it's not convenient to be consumed by upper layer. That's the reason or goal of a Feilong project to be there. So Feilong is providing a Python-based REST API interface to be consumed by upper layers such as OpenStack. So in this picture, OpenStack compute node, it has Noah and Neutron, which is focused on compute, network, and other things. So the management request is coming from the controller, and it will be sent to different compute nodes based on the scheduler or based on the request, the administrator or the user's request. Then the compute node such as Noah or Neutron is going to talk to Feilong or ZVM Cloud Connector. So it's REST API based, and in order to use Feilong, you have to have a Linux server on top of the ZVM. So as you can see here, there is a Linux service running on top of a ZVM. That's the pre-requirement because the ZVM Cloud Connector is a Python-based solution. You need to install or Linux install a Python environment, and for example, like a C language or Linux runtime in order to have a ZVM Cloud Connector running. You don't need to have a high privilege user for that Linux server because ZVM Cloud Connector is talking to SMAPI, and all the privileged user is inside the SMAPI. So ZVM Cloud Connector or Feilong is talking to the SMAPI to do the management. It doesn't need to be high privileged user on ZVM. So that's the overall architecture of Feilong and ZVM Cloud Connector. Next, I'm going to talk about the overall architecture about Feilong itself. In previous chart, we talk about the use case or the user scenario of Feilong project. Now in this page, we're going to talk about the overall architecture of Feilong. First, it has a REST API layer, right? So it's Python based. all the code about in the REST API layer is a Python, and it has the REST API request server that can accept the request from out layer, such as OpenStack or VMware or other things, or anything that you can take as a REST API client. The REST API server, it can accept requests such as a post request or get or put. So it depends on the requirement or depends on the resource that you're working on. So this is the this is the API REST API layer, and then we're gonna have a transition layer. We call it transition layer because it's a primary doing the logical transition from the request, such as a REST API server. So it will get all the requests from there, and it will do all this job, such as the image management or host or virtual server or whatever. It will do the primary logic here, and it will finally call the SMCRI layer, which is a DHCP. We're going to talk about later. The transition layer is multi-thread. It's not single. So the default thread number is 64, and of course you can configure it based on your requirement. And at last, it's a DHCP layer, which we usually call it SMCRI. It's totally written in C language. The purpose of this layer is only to wrap the SMCRI SM API call. As we mentioned, SM API is socket-based, so we need C language to talk to the SM API in order to do the real request to the SM API. In the meantime, there are some SM API return code, such as a timeout or retry or asynchronous call, such kind of functionalities from SMCPI. So the SMCRI layer is responsible for handling that project, handling that request, and do the retry or whatever thing that need to be done. Next, we are going to talk about the detail of what REST API layer. So basically, the REST API layer is running on a HTTP service or Nginx or whatever HTTP servers that you're running. Feilong project itself doesn't create a HTTP service. It's just embedded into the existing HTTP server. And let's see we want to have create a new guest. So the grammar will be very simple, which is, let's say you post the servers and you want to create a server. Okay, then the server name is ABC, and as you can see here, the REST API is the post servers ABC, and you can add additional parameters as you want. So all the things are already documented in the Feilong project documentation, and you can refer to that documentation for further information and check the parameters there. It's very to extend this kind of APIs. For example, previously we don't have management for the host, and when we design the first Feilong API, we only talk about the servers, which is virtual machines lifecycle management. And then we find, okay, actually we need to manage or to get further information from the ZRAM itself. We abstract the concept of a ZRAM into a host, and we added a new REST API resource called post or called host, and then we can use it as a resource endpoint to talk to. And then the REST API layer is actually, we are trying to make the API the backward compatible. So it's design consideration. So whenever we make changes, we need to consider whether it's backward compatible. Because let's say you have a version 1 and now you have version 2. So if you upgrade from version 1 to version 2 and the API is incompatible, that means the upper layer, I mean the consumption, like the application or Ansible script or whatever, actually they expect the API have such kind of mechanism and response. But if we make API incompatible, then all those functions, all those consumers of the API need to be rewritten, and that will be unacceptable from an application development perspective. So that's the design consideration for the REST API layer. And the next, this is a transition layer. And in transition layer, as I mentioned before, it's accept request from REST API layer. We technically say it's transition layer, but all those things are written in Python. So it's kind of accept the request from REST API, and it handles the detailed logic. So there are a set of concepts in Feilong now. For example, the image, because Feilong is a virtual machine lifecycle management. It's not like a ISO image, which is you get an ISO downloaded from some distributors and you install it from somewhere and do the configuration extra. It's kind of cloud concept for Feilong. So you have to predefine or pre-create an image, or for example, you can get this image from somewhere, from your vendor or from somewhere or made by yourself. Then there is an abstracted image concept. You can export this image, you can create an image, you can upload this image, and of course, the primary use case is to import or upload the image from somewhere to the existing Feilong cluster. Then you're able to use that image to provision a virtual machine. So next is a vSwitch. And Feilong is not a virtual machine centric, because as you can see, when you create a virtual machine, actually a lot of resources included, such as a virtual machine, storage, and network. So in order to manage vSwitch, for example, I can define vSwitch, I can couple NIC to vSwitch, I can revoke NIC access to the vSwitch, extra. So all these APIs functions are already defined there. So you can use the REST API to call to the vSwitch and do management. Next one is host, as I just mentioned. The host concept is actually abstracted by ZVM. For each ZVM, you will have a resource called host. We distinguish those ZVM hosts by their name. So we didn't provide, until now, we didn't provide any create a ZVM concept in the API, because we cannot do so unless you want to automatically install ZVM, which is not something that can be supported now. So the API that's supported for ZVM and host is get. So you can get information from the host, for example, the disk pool that you use, or CPU, or memory, or other things that you can get. You can get those things from the host. Last one, which is a virtual machine. And this is the most important concept of the whole Feilong, because the Feilong's primary focus is the virtual machine lifecycle management. So let's say you want to define virtual machine. What you need to do is you need to prepare an image. And then you create a vSwitch. And you define a host. Now you can, start virtual machine. Start to define a virtual machine and prepare user directory. And in the user directory, you can define the memory, the CPU, and other informations in a REST API call. In the meantime, you also need to define the network that you want to connect to, or vSwitch you want to connect to. So this will also be parameter to the virtual machine create. and last, you want to use the image. So Feilong is going to help you in copy the image's content into the virtual machine that you're going to provisioning. And Feilong is also leveraging the open source famous active engine, which we call Cloud Init. So Cloud Init is something that can help you doing the initialization of the virtual machine. That virtual machine will be, for example, the host name will be changed, the IP will be upgraded, and the disk, for example, the image is maybe 5 gigabytes or 10 gigabytes, but you deploy to let's say 20 or 30 gigabytes disk, then that's something that you can use. And Feilong will automatically help you to increase the file system from 5 gig to 5 gig or 10 gigabytes to 20 or 30 gigabytes. So you can utilize full disk by own. And all those functionalities actually, especially those things that interact with the DHCP layer, is going to call by DHCP layer. So the image management or the virtual machines content management, such as a copy from the image to the virtual machine, is not going to call the SMA API layer. But for something like a defined user directory or a couple NIC, those things that need to be defined is in a ZVM, CP, or user directory or daemon. That's something that we're going to call the DHCP layer, which I'm going to talk about later. So this is the DHCP layer. As you can see, it accepts the request from a transition layer. The transition layer called DHCP, and this DHCP is a C-based wrapper. Why we need this? It's because the SMAPI is a socket. So we have to use socket to talk to the SMAPI and do the management. And there are other things that need to be handled in the DHCP layer. For example, there might be some timeout. SMAPI is not functional. How can we handle that? So it is wrapper in the DHCP layer. And as you know, the SMAPI, the daemon is which is talking to the daemon, which is manage the user directory. Its performance will be improved later. So in some very rare case, the daemon or SMAPI will be a little bit slow, and it will not return back immediately. Instead, it will return a synchronized ID to you and notify that this is something that we are working on, and you need to subscribe this synchronized ID in order to know whether it's finished or not. So it will return a synchronized ID with some special error code. So the DHCP layer handle that special error code and do the check for the asynchronized ID to see whether the transaction is already finished or not. Of course, there are some other errors, right? So one might return errors, and the DHCP layer is responsible for that layer's handling, such as report some meaningful information to the upper layer instead of just return the error code that administrator checks might be error. That will be something not helpful for the admin. So that's the use case. That's the purpose of the DHCP layer. And at last, I'm going to talk about integration. So there is a new offering inside IBM, which was GA last year, called IBM Cloud Infrastructure Center. The link is provided here. As you can see, the IBM Cloud Infrastructure Center is the IBM Z and Linux One only offering, which means it is only functional on it is functional and specially designed for IBM Z and Linux One platform. It's working as an infrastructure as a service to provide the lifecycle management of the virtual and physical resources. For example, currently IBM Cloud Infrastructure Center support virtual machine lifecycle management, support storage like storage family or DSAK, such kind of storage management. And it also plans to expand its scope to support such as OpenShift, which is utilizing IBM Cloud Infrastructure Center as the ICE offering to provision resources in that needed for OCT cluster. Also, it's helping. We're targeting to working on other things like network, load balancer, extra. So Feilong is a very important part of IBM Cloud Infrastructure Center, which is to be consumed by IBM Cloud Infrastructure Center to manage ZVM, virtual machine, and other things as a lifecycle management. In the meantime, there are also potential use case for the VRA and VR workflow. Currently, there is a bank customer integrate into their automation flow. So they are using VRA and VO. There's a whole flow to do the lifecycle management on Linux One machines. It's not only for virtual machine, but also for application, for other things. So one of their workflow is to provision virtual machines through Feilong and IBM Cloud Connector. And after the virtual machine is deployed, the other flows are going to install applications or database into the virtual machine that deployed by Feilong project. And of course, there are other potential use case for Ansible playbook. So you can technically write an Ansible playbook to be integrated into other Ansible-based solution to drive the lifecycle management on top of ZVM for the virtual machines. So that's all for the integration of the of Feilong project to the upper layer. And that's all for our presentation. And thanks all for your listening. And feel free to contact with us if you have any question or any comments on the presentation. Thank you.